welcome to Summary Notes episode number 4. In this episode, we are going to cover concepts from lesson 1.3a to lesson 1.3c. So let's go ahead and get started on our front page here, which covers all of lesson 1.3a. As you can see in this lesson, the main concepts or main ideas or what we've talked about, is the distributive property and combining like terms. So I'm going to go ahead and get my highlighter out and highlight those two main key concepts. Now, the distributive property and combining like terms are concepts that you've learned since 6th grade, but it's important that we revisit those two concepts and the skills that I need you to know and understand so that we can move forward in our future lessons as we continue our time in algebra together. So the distributive property, as you can see under here, says when a number is outside of a set of parentheses, distribute, which also means multiply, that number or multiply it over addition or subtraction of terms. So as you can see below here, I have two different examples. A dead giveaway, if you have to use the distributive property, is if parentheses is present in your problem or in your examples. So in this case, as we can see in both of my examples, I see that there's at least one set of parentheses, and there is a number or a constant or a variable that's out front that I need to distribute into the terms that are within the parentheses. Now, if I look at this first example here, I notice that 3 is the number that I will be distributing to the x and to the -3. And since there's a subtraction symbol in between, we call this example the distributive property over subtraction. So I'm just going to write that off to the side, that this example is the distributive property, and I'm just going to abbreviate those words. So distributive property over subtraction. What's nice about identifying that it's over subtraction is that it helps you, like if you say that or if you remind yourself of that, it helps your brain realize that this subtraction symbol is actually making this 3 inside the parentheses negative. So it's something to keep in mind as you distribute. So in order to carry out the distributive property, I'm going to take the 3 and multiply it by my first term, which is x. So 3 times x is 3x. And then I'm going to take my 3 and multiply it by the second term in the parentheses, which is this -3. 3 times -3 is -9. So now when I look at my expression, I can see that I have two total terms. I have a 3x and a -9. And to me, neither of these two terms have anything in common. So this is my simplest form, or technically this is my solution. And again, pushing you to where I need you in the future, we need to make sure that this solution is organized from highest exponent to lowest exponent. And since we don't have any exponents higher or over, or to and over, I can see that I have this in order because it's highest exponent to the lowest exponent, or my constant is last. So this right now is what we call in simplest form, meaning I can stop at this point and circle or box in that as my solution. In the second example here, instead of just a number, I have technically a number or a -1 and a y or a variable. So I can still distribute this -y into my parentheses. And this time when I look in the parentheses, I see an addition symbol. So this is called the distributive property over addition. So again, off to the side, I'm going to write distributive property, and just abbreviate that, over addition. Okay, so now I'm going to go ahead and take -y and multiply it by a -6 to begin with, or that first term. So to me, what I like to do is I like to look at the coefficients, or the numbers I'm multiplying first. So here, this negative represents a -1. So a -1 times a -6 is a +6. And then I have this y, and so that is just going to be +6y. So a -y times a -6 is a +6y. So then I'm going to go ahead and take -y, and this time multiply it by the second term, which is a +y. So a -1 times a +1 is going to be a -1. So I'm going to start by putting in my subtraction symbol to represent -1. And a y times a y, as we've discussed in the past, is how I get y squared. Remember, y plus y is 2y, but y times y is y squared because we have to add those exponents together, which we'll cover when we go over lesson 1.3c. So now if I look at my expression, I have a positive 6y and a negative y squared. Two terms. However, I cannot combine these two terms because y and y squared are not the same. They're not alike. So technically this is in simplest form. But if we're going to practice writing our expressions from highest exponents to lowest exponent, I need to switch these around because the exponent of 2 is higher than technically the exponent of 1 that is on this y. So I'm just going to go ahead and flip these terms places, keeping y squared negative, so it starts out as negative y squared, and then adding or making sure my 6y stays positive. So this is my answer then in simplest form, and it's written from highest exponent to lowest exponent. So that would be my solution. So 2 examples where I had to use the distributive property. So then if we go down and look at combining like terms, we need to remind ourselves that in order to combine like terms, you need to make sure or notice that when there are terms in expression of like terms, you need to add them or subtract them in order to get them together. So in this example, I have a negative 10x squared plus 3y minus 8x squared plus x. So when I look at this expression, I notice there are 4 different terms. So the first term is negative 10x squared, second term is 3y, third term negative 8x squared, and fourth term is positive x. And when I look at these terms, I notice, or to me what stands out, is that negative 10x squared and negative 8x squared have terms or have variables that are in common because they both have an x squared. So my first step here would be to combine these two values or these two terms. So if I'm at negative 10 on the number line and I subtract 8 more, I end up at negative 18 and then x squared. And then when I look at the 3y and the x, I can clearly see that these are not like terms, so I cannot add them together. So I'm just going to go ahead and copy the plus 3y and the plus x down to my next step. So remember, these two are the only like terms in this expression. So now when I look at my expression, I can't combine anything else. So this is a 3-term expression that doesn't have any more like terms to combine. And I've organized it from highest exponent to lowest exponent. So this would be my solution because it's in simplest form. And I'm just going to write that off to the side. So when you are needing to deal with the distributive property and combining like terms, there are a couple steps that you want to think about in order. So that's why I have this lovely little thought bubble off to the side here. So when you are asked to simplify expressions, the first thing you need to think about is, do I need to distribute? If you do, go through that process in order to start getting your expression in simplest form. If you don't, or after you distribute, then you head to step 2, which is asking yourself, do I need to combine like terms? So again, if you have like terms, go ahead and do it. If you don't have like terms, then you're done with that step. Step 3 then is asking yourself, is it in simplest form? So after you have looked for the distributive property or looked for combining like terms and have carried out those processes, you want to make sure that your expression is still in simplest form. And then finally, step 4 is like pushing you further and thinking about where we're going in the future and making sure that your expression is written from highest exponent to lowest exponent, making sure that your constant is at the end. So this is a good 4-step process to help you think about when you are simplifying expressions, how you go about using these concepts kind of in order. So I'm going to go ahead and stop this video, and in the next video, we are going to go ahead and finish these 2 examples at the bottom.